Okay, I got a number line here, and how many numbers are there on that green?
Infinite.
Oh,
Like integers or like
numbers,
so
real numbers.
infinite.
There is infinitely many numbers there. Okay. In fact, the real number line is so dense between any two numbers, no matter how close, there's still an infinite number of numbers in between there. So this is all the numbers between 2 and 5, including 2 and including 5. This is called an interval. An interval. Okay, so an interval is a continuous set of numbers between two numbers, known as the endpoints. You can include them or exclude them as still an interval of numbers. Or it's a set of numbers. It is an interval. Okay. Anytime you have an interval, we can use, it's called interval notation. To write down the set. Okay. We would not use the curly brackets here. Why would we not use the curly brackets here to write all the numbers? So interval notation is a way to write sets. This is actually called roster notation. Why could I not use interval notation? Sorry, why could I not use roster notation? First off, I'd have to write an infinite number of things. We can't write down an infinite number of things. And we can't write it as like a pattern with the ellipses because I'm missing lots of numbers. Like what number am I missing between 2 and 2.1? 2.05, 2.01, 2.001. There's no way to write them all down. So we write them down a different way. And that's called interval notation. Since they have endpoints, we only write down two numbers, the left endpoint and the right endpoint. So here, the left endpoint is 2, and the right endpoint is 5. And then we either include those numbers or exclude them. Here, I filled in the circle, so 2 is in that set. If it includes the endpoint, we put a square bracket. Both of these are included, so I put another square bracket. So this is the set of numbers between 2 and 5, including 2 and 5. Let's do another example. This is an interval, since I changed in every number between 1 and 4. And what does the open circle mean? Not included. So we took out that one or the 1 point on the line. So we still put the smaller number to the larger number. To exclude it in interval notation, we put a round bracket. So this is all numbers or the set of numbers between 1 and 4, not including 1 and 4, or excluding 1 and 4. Okay, this is called a closed set. And this is called an open set. You'll learn why later it's called open and closed. So this is another set, sorry, another interval. We include the -5, exclude the 10. So in interval notation, go -5 to 10. We include it, so again, square bracket. We exclude the 10, so round bracket. Okay, this is called half open, half closed. Because we included the smallest number, -5, that half is closed, the right half is open. There's another half open, half closed set. So what number do I write first? 0, the smaller of the two numbers, endpoints, and then pi. Is it round or square around the 0? Round, we don't include that. We do include the pi. So this is also an interval. It doesn't have a right endpoint. So it's all numbers between 4 all the way out here forever. All numbers greater than or equal to 4. So we definitely write 4 first. And since it has no ending here, it goes all the way to the right forever. We put positive infinity. We include the 4. And we never include infinity or negative infinity. Why would we not include that?
Always go past.
Well, there's really nothing to the right of infinity. Okay, the reason we don't put a square bracket is because infinity is not a number. It's not a real number. So we don't include that. Just means all the numbers being 4 all the way to the right forever. Okay, again, this is a half open, half closed set. We can go the other direction. So here we go, all numbers less than 3. Since this doesn't end, it's from negative infinity. Round bracket, always with negative or positive infinity. And then 3, do I do a square or round bracket? Round, because we're excluding 3. That's that set of numbers. And another example, every real number. This is the set of real numbers. I think I wrote this down the other day. It's all numbers between negative infinity and positive infinity, and we exclude both. We wrote that down, right, on Friday? Okay. This is the same thing as the set of real numbers. 2 different ways of writing the set of real numbers. This is interval notation. This is just the symbol we use for it. On this. Okay, let me go back here for a sec. This is all numbers between 1 and 4, correct? Excluding 1 and 4. What if I just wrote down the very beginning of class? Is this an ordered pair or an interval? Right. If you see this now, is this an ordered pair or an interval? Interval. How? Why is it obvious? It's a square bracket. Okay. When they're both open, it looks exactly the same as an ordered pair. Okay. The only way you know the difference is we're talking about intervals of numbers. This would be an interval. If you have no context, we don't know if that's an interval or an ordered pair. If I said graph the ordered pair, then we would definitely know it's 1, 4. Okay, they look exactly the same, so be careful with that. Make sense? Okay. What do we call this thing that I've written on the board? An inequality. Is it true, false, or open? Are the solutions numbers or are they ordered pairs? Numbers. Why? There's only one variable. Okay. We're going to solve this. And what's it mean to solve?
To find a solution.
Find the solution set. And what's a solution set?
A set of all solutions.
The set of all solutions. What is a solution? When the number is replaced for the variable that makes the inequality true. Okay, we're going to solve this. You saw these last year, I think. What, subtract 5? And then when we divide by -2, what do we have to do? Flip. Yeah, x is greater than or equal to 8. And is this my solution? No. What is this? Another open inequality. Solutions are numbers. Okay. The graph of the solution set. We need a number line. Makes all numbers greater than or equal to 8. And is the solution set an interval? It is an interval, so we can write the solution set in interval notation. It is all numbers between 8 and positive infinity. Square bracket, round bracket around the 8. Square, we include it. Square roundabout around the infinity. Why round? It's not a number. Okay. This is the only way to write down the, well, I shouldn't say that. This is the solution set in interval notation. This is the graph of the solution set. Ordered pairs, why?
Two variables.
There's 2 variables. Okay. Okay. The 2 variables. Before we get to that, let me write down this equation. How many solutions does this have? Uh-oh, we went over this on, right, infinitely many, right? And we graphed the solution set. Two. Intercept of 2, slope of 3. And we talked about Friday. This is the graph of the solution set. Everything in purple here is a solution. Everything not in purple is not a solution. We agree?
Yeah.
Okay. Are all these ordered pairs? These are a bunch of ordered pairs. Are all these ordered pairs solutions to this inequality? Somebody give me an idea. What you think?
Like, so like the graph does, it is like all the solutions for the inequality, but like, it's not like all the solutions for the inequality, but those are all like the inequality true.
Okay. That's correct. So this is a 1, 5, right? It's a solution here. Let's check to see if it's a solution here. Is 5 less than or equal to 3 times 1 plus 2? Is 5 less than or equal to 5? Yes. You take any ordered pair on that purple line, plug it in, you'll get this number exactly equals this number. Because the or equal to, for sure it's going to be a solution to this too. Does this make sense? Okay. So everything in purple here is a solution to this, and there's way, way, way more. Okay. And the way we do that, I think you did this last year. We do like a test point. You take any ordered pair not on that line. I always pick 0, 0 unless the line goes through the origin. And we test it. We go 0 less than or equal to 3 times 0 plus 2. Is this true?
Yes.
0 is less than or equal to 2. It's less than. Okay. So this right here is a solution. Okay. And therefore, everything on this side of the line is going to be a solution. Every ordered pair on the other side will not be a solution. If we did a test point and it was false, we would not shade this side, we'd shade the opposite side of the test point. Okay. So now we just got to put dots on every single ordered pair. There are so many solutions to this inequality, it fills up an entire half a plane. We sometimes call this the solution set a half plane. Okay. Can I write the solution set in interval notation? Can I, oops. Can I write everything that's shaded in interval notation? Like I did right here? The answer is no. Intervals are sets of numbers, not sets of ordered pairs. Okay. Only equations in one variable can you write in the solution set interval notation. Okay, the only way to find the solution set is to graph the solution set. Okay, what would change if it was strictly less than? Okay, if it was strictly less than, everything that's a solution here would not be a solution. Okay, and instead of like we did up here, putting, where did we put it? An open circle, we basically put open circles on this entire line. But we don't really put open circles, we just put a dashed line. Okay, so we would put a dotted line. That means exclude the that line, all the ordered pairs in that line. Okay, let's try another one. And we got two variables. We're going to graph on a number line. Sorry, we're going to graph on a coordinate plane. Sorry, let me erase this. I want strictly less than. We start by graphing this line. Okay. Am I going to put a dotted line or a solid line? Dotted. So all these solutions to this are not solutions here. So we exclude the boundary. And then what do? A test point. Again, let's test 0, 0. 0 less than -3 times 0 minus 2. Is 0 less than -2? 0 is not less than 2. This is false. So this test point right here is not a solution. It failed. So that means everything on the other side of the line is a solution. So we just start shading this side of the line. And for an inequality of two variables, you almost always end up with a half plane of solutions. There's a lot of them. Okay, what questions do we have on this? You guys did this last year or no? Yes. Okay, so this should review, but very important. We got to understand interval notation and know when you can't do interval notation. Those two variables.